right, I guess we can go ahead and get started now. Or I should really say we should continue since we started about 30 minutes ago. Is there anybody here who did not come to TJ's talk in this room? Okay. So that's good. It was really boring. You did not miss anything. So he did cover a lot of the stuff that I'm going to cover, so I'm going to speed through some certain parts, maybe touch on a couple of things. If anybody has any questions, feel free to shout them out. This is not super formal, so just throw it out there if you got it. I am David Coursey. There's my contact information. I got a couple certs. That is not actually me. I've been doing security engineering and systems engineering for about 12 years for commercial, and now I guess the last 5 has been defense. So I've got both ends of the spectrum on how things are done or not done. So moving right along, the Microsoft Enhanced Mitigation Experience Toolkit. I hate saying it, it's a terrible name, but it is one of the most undervalued utilities for endpoint protection in a Windows domain that I have come across in a long, long time. Most people did not even really start hearing about it until, maybe they were putting out version 3.0. Now they're on 4.0, came out just a couple months ago, and it's still not getting a lot of press, which is odd for Microsoft since usually they throw a lot of marketing money at anything that's doing well. So I usually give this talk for less, or the last time I gave this talk was for less sophisticated security professionals. So just the quick background is, since the dawn of time, we've been using firewalls to protect our assets, our flock. And for a long time, it was very successful, and that was all we needed to secure our networks. You just put a little flaming brick wall on your Visio diagram, and then we got really advanced. Then you had 2 flaming brick walls, and as the firewalls got better, the attacks got better, and it became a war of escalation until attacks were just completely bypassing firewalls and going straight for the members of the flock. And it's pretty safe to say these days that our flock is difficult enough to control on their own without any outside. For a long time, they were given the run of the pasture. They could do anything they needed. Operations and functionality was paramount to everything else. And sooner or later, one of them would jump off a cliff. So a lot of people worked on these problems for a long time, and we took the exact same strategy as we did with actual sheep. We started putting up fences. And the fences are very strong mechanisms for controlling application behavior, for inappropriate behavior, prohibited behavior, or anything that we just don't want to happen. And if anybody would like me to cover these again, feel free to shout it out. The only one I'm going to cover is, I'm pronouncing it CoOp, but I don't really know if that's proper. The last 2 were covered very extensively in this talk. So DEP, data execution prevention, ASLR, address space layout randomization, and secure exception handling overwrite protection are the 3 primary fences used to control applications in Microsoft environments. So CoOp, structured exception handling overwrite protection, is a mechanism used to control where program failures progress next. So structured exception handling is a method in Microsoft programming used to say, when this program fails, I want to tell it to go here next so that we can fail safely and not blow up the entire system. So if you look at the all of the exploits in the Metasploit framework right now, about 20% of them use SEH to direct the flow of execution through forced program failures. So CoOp blocks that, and it's similar to the way ASLR randomizes the layout of memory, but it randomizes the function addresses for the exception handling methods inside of Windows. So it's just one more fence, and they work pretty well, but once all the fences were put up, what happened next? The pen testers came in. Sometimes they're authorized and sometimes they're not, right? So as soon as all of these protections were created, the bypasses were created probably less than 5 minutes later. You can go on the internet, and every single one of those you can find a very easy bypass method for getting around it. And so Microsoft started doing some research. They put out the Security Development Lifecycle Progress Report. They took 41 consumer applications, very large, with millions of users over a period of a couple years, and started looking at what protections were being used in these applications to use defenses, use the operating system methods that were already in place to protect the endpoints. And DEP is okay. I think this is 71%. ASLR is 34.1% for those applications. And I'm pretty much in the camp that anything that's partially enabled as a security feature is a waste of time and probably should not be enabled at all. So what does that say for the way applications are being developed for large consumer applications? They're not using all of the security features that are built into Windows. But what does that really say for all of the custom line of business applications that only have a few users but are critical to your business? You could be a Fortune whatever company with a development house of hundreds of developers, and do you think they're going to fall into that category? Not enabled? So here's the pop quiz question for my giveaway, which is an awesome little lockpick set from Fail. What does it take to enable ASLR and DEP on a Windows application?
Oh, me! I know this one.
You have a blue shirt on, you can't answer.
Exec compile time is the first time you can do it, and you can use EMET, and then def is.
Right, so it's a compiler flag. So I looked into it a little bit. You open up Visual Studio, and it really is that simple. Randomized base address, default. Data execution prevention, default. And then I think error reporting is the CoOp. So those three, click a couple check boxes, recompile the application. I'm not oversimplifying this at all. Do some testing maybe, and you now have these protections enabled. But it's obviously not being done because the developers are not being pushed to use security mechanisms. That doesn't sell software. So what the people at the Microsoft Security Response Division got the idea that we needed something a little bit smarter than a fence. We needed something that could actively seek out inappropriate behavior, and that is the sheepdog. So that brings us back to Microsoft EMET. Microsoft EMET is a very small .NET 4.0 executable that it's not a blacklist, so it doesn't require signatures and constant updating. It doesn't actively block anything in your system, and it's not really a whitelist because you're not making a big list of things that are approved for use. So it doesn't actively block any kind of connections or do anything like that. It's just good programming mechanisms. It's just forcing the Windows operating system forcing the applications to use the built-in protections of the Windows operating system. So you could say the same thing about a lot of the host-based IDS, IPS systems. What about maybe I know there's a lot of defense people here, so what about HBSS? Doesn't that do the exact same thing? And the difference is those are blacklist and whitelist based, and they're extremely complex. Anyone who has tackled the squeal install process would have a very difficult time upgrading HBSS. It's a monster, and nobody shout anything out, don't say any names, but how many times have you looked at an HBSS deployment where things were installed and it wasn't actually doing anything? It was a checkbox, yep, we got HBSS. So,
Secure.
yeah, exactly. So it's installed. They made it through the install phase. So, what is the counterexample like for EMET? So, just to walk through a quick installation, because I want everybody to be able to take something back to their jobs on Monday, 7 a.m. and get things started. So it's just like every other Microsoft installation you've done. I agree. Next. And then you have to make a decision. For the purposes of doing it on your home stuff, just use the recommended settings. Everything is very easy to back out. So if the recommended settings don't work for you, or if you feel like, just leaving it blank for now, it's very easy to change. Once the install is done, you have the EMET service running, and you have the EMET GUI installed. So you launch the GUI from the start menu, and this is the first screen you look at. This is your list of running processes. And on a brand new system, nothing is enabled for EMET. And you may or may not have some stuff going on for the system status. So as you start poking around, you see that the system status is whatever your domain or your workstation is already set at. And this is where you enable things on a system-wide basis. This is pushed out no different than a GPO setting or a local security policy. That's exactly what it is. A registry key, if people are still doing that. And this doesn't affect any applications that are not compiled for ASLR, not compiled for DEP, or even worse, specifically are using mechanisms that require those to not be available. If we back up and look at the list of running applications, then you can go in, select one, and we have just a slew of available protections for Internet Explorer. All you need to do to protect Internet Explorer for all these protections, check 3 little checkboxes and click OK. And when you do that, all of those things that TJ was talking about in his talk are blocked because all of the protections on this work simultaneously. Anytime you have DEP or ASLR enabled or CHOP, if they're not running together, they're not running. Everything with the bypass, all the bypasses require some other mechanism to not be available in order to bypass the attack, to bypass the protection. So, especially DEP and ASLR. So, you now have Internet Explorer protected, and everybody's happy, right? But not really, because we've built careers on wanting to know how everything works. So I think 2 other talks already have talked about shims. So if you missed one of those, this is a mechanism used to tell a program to go somewhere else. Pretty much just like the attackers are doing, but it's in a safe, logical way so we can direct things away from where the attackers want them to be directed. So in the case of EMET, the import address table holds the addresses for all of the loaded DLL's methods for operation. So an attack is going to look at a loaded DLL and say, I want to execute, or I want to use the register that is pointing to this function. So the shim points to EMET first. So EMET takes all of the DLL calls, or all of the system calls, and modifies them to a safer version of the call, for lack of really understanding it myself. So the shim just says you're not going to make unsafe calls. Now, granted, there have been bypasses for EMET, so it's going to continue to have a war of escalation. But for the time being, with EMET 4.0, there are no EMET bypasses. So an application with this shim running in it, there is no way to make unsafe system calls through those loaded DLLs. And that works for static and dynamically linked. So you're not going to be bringing DLLs in on already running systems and thinking that you're going to get around the EMET protections, of which there are many. And a lot of people don't even understand what they do. Specifically, bottom up. So you'll notice that some of these do not work on XP in 2003. And that's just something we're going to have to deal with, but it shouldn't be a big deal because nobody uses those anymore. And a lot of this stuff is built into Windows 8 and Server 2012. And in the defense world, EMET is now a mandatory STIG check on Windows 8 and I guess eventually Server 2012. So those are, they're here to stay, you know. So all these protections are done simultaneously, and that really just blocks everything TJ was talking about. It's very simple and effective, not much to say about it. But there is one other very large feature that's not getting too much press in EMET 4.0, and that is the PKI certificate pinning mechanism. So if you have a default Windows install right now, I think there's 18 trusted routes for certificates. I've looked through them. I recognize a couple of them, but most of them I've never heard of. Most of the stuff I do through my job goes all through DoD routes. All of the stuff I do at home probably uses one or two of the trusted routes. Nobody removes any of them because you don't really know what's going to happen. So if you follow security news, you hear a lot about how PKI is dying, and in 5 years PKI is going to be completely dead. We better hurry up and find something quick, or else we're all hosed. So in the meantime, what you can do with EMET is you do certificate pinning. You open up the GUI and you tell you want a new trust rule, and for a site that you use, for a site that you want to be a protected site, you import the certificates, and you could do the root certs and you could do the intermediate certs, but you say these are the trusted roots for this website that I like. So for BSides, you would import maybe VeriSign root CA. And so you create a trust rule, a pinning rule. Once you do that, you come back over to the other tab and you tell the website that I want to go to is going to be pinned to that pinning rule. Now you could mix and match. Maybe you just say VeriSign root CA and mix and match websites, but for the purposes of this talk, I didn't do that. So when you do that, anytime your system tries to access that website, it will not function if you get a certificate from a different root CA. So why is that important? Anybody?
So, because if a different root CA gets compromised, they no longer issue a valid cert for another site that they should not be issuing certs for. Your computer will not trust it.
Correct. If a root server gets compromised, starts putting out bad certs, or if someone at the root CA in Kenya wants to make a little bit extra money and sends out bad certs, or if you're being man in the middle and you're getting a self-signed certificate in your Java applet, or you want to just make sure that maybe you only want to use the DoD routes, or maybe you only want to use your local OCSP responder. It's just more tight control, so you limit the exposure on the PKI side. pretty powerful. I haven't done too much with it, just because it's kind of new and I don't do that much web stuff on my Windows box. But for large organizations where you have users that need to get out to sites that are typical avenues of attack, like Facebook, you can do this and kind of mitigate between now and whenever we have PKI 2.0. So what does EMET not do? There's not too much bad news here because it's just a small application, so there's not a lot that can go wrong. You do need to test your applications, your custom applications, before you put it in place, just to make sure you're not going to blow anything up. If, go ahead and roll it out to a subset of users, but for someone who does not have a comprehensive security team, putting EMET on your 25 workstations is going to be a huge step forward for not getting compromised. Other than that, it's not magic. So there are programs that are written so poorly that they require you to not have ASLR. And EMET is just not going to allow it. So that's where you have to go back in and you exempt your one custom business application and you just keep it enabled on Acrobat and Java and everything in Office and Internet Explorer and Firefox, Chrome. Some of these applications that may not have their own protections through GPOs. I don't think it's too far off to say that they're going to see their own attacks.
If you push EMET to your systems and the user installs, say you push EMET and include the Firefox components. The user doesn't currently have Firefox or Chrome, but then they install it. Will the EMET rules then apply?
So the question was, if you have EMET pushed out with a rule that turns on the protections for Firefox or Chrome, the user does not currently have those installed, but then does later, will the protection apply? And the answer is yes, because it applies through the currently running process. It doesn't do anything at install time.
Okay.
It doesn't.
So you can have EMET rules for software that's not installed on every system.
Correct.
I could have one global EMET deployment and whatever subset of applications I have on my system will then be subject to these.
Correct. Yep. And speaking of deployment, it is deployed and packaged just like everything else in your enterprise. Maybe you use GPOs to push things out, or maybe you have I can't remember the name of the big package manager. Yeah, or maybe you just have the intern run around to 5,000 desktops. It doesn't require a server infrastructure or any kind of care and feeding, other than a very little bit of management. It's managed through GPOs. They have a custom ASDM file where you can pull in the GPO settings. Just set up an Active Directory group for EMET protected computers and roll it out. The Jonathan Ness from the Microsoft Security Response Center, I heard him talk on this on paul.com, and he was saying that they are taking all the feedback that they get on EMET and rolling those protections into the new updates in Windows 8 and Server 2012. So this is really the test bed for all of their security protection mechanisms. You might expect to see some kind of certificate pinning coming in maybe Windows 8, Service Pack 1. And that's just a complete guess. But it is they do watch it. It's something that the security team is very proud of, even though Microsoft as a whole may not be pushing it. There is a support forum on the TechNet section. The subscription is going away, but the TechNet website is not. So if you don't have an active Windows support contract, many of us probably do, but if you don't, you can just go on the TechNet forum and get help from EMET. And that's really about it. It's such a small application. It's so very simple that it doesn't need a lot of explanation, especially after 2 people have given talks on it and half an audience. So if anybody has any questions, feel free to throw them out. Otherwise,
What kind of problems?
What kind of logging does it do?
Okay. So it logs to the Windows event log, and it does a sys tray pop up. So the question in my mind that I have not yet sufficiently answered is, what happens to some of these protections that are proactive rather than reactive? If it blocks an ASLR-based attack where the thing that the attack was looking for just isn't there, does it have an event log that says somebody was looking for a thing and it wasn't there? I don't really know yet.
Which event log, in the app event or sys event?
I can go back and look in a minute, but yeah, I think it's application.
I grab all three, so.
Yeah. It's not security, I know that.
Okay.
So it's either system or application.
Probably depends on what it blocks specifically.
Yeah.
What problems have you seen with it?
So I threw a lot of attacks at it. The application either fails spectacularly, like you open a crafted PDF and Acrobat just blows up, or it just silently blocks it and you never knew anything existed. Like if you're going in IE to a Metasploit hosted or like a set hosted web page, you download an encoded executable, IE just sits there and does nothing. So
What
there's,
about legitimate? Have you seen problems with legitimate anything?
I have not seen people deploy it on applications that were legacy and old and crotchety. People do it, the people that I've seen do it, Acrobat, Java, Office, Internet Explorer, the browsers, the main points of entry. The people that don't do any security on the old legacy applications aren't going to do this either.
And you've managed it through group policy?
Yes.
It's pretty simple, no
Yep.
problem.
Yeah, I mean, if you do any GPO work at all, it's absolutely no different. It's the same as like an Office GPO, where you import the ASDM template, and you just have to know where to go to get the new drop-down boxes.
When you deploy it on those popular applications, do you just go full bore, like checkboxes across?
I have.
Okay.
Your mileage may vary, but those are the ones that have been tested the most. So those are the ones that are going to have the most people screaming.
So concerns me when it blows up, it only logs locally. Is there any facility to capture that as an alert message up somewhere?
I don't think there's any. I know there's not any syslogging, and I don't think there's any emailing mechanisms, although I could look it up in just a second and let you know.
Is there any move to streamline it into System Center as part of Config Manager involvement?
I don't know. It's a very good question. As far as I've seen across the board, Microsoft's strategy is pretty much event log. So I don't know the answer to that.
Would this hit, you may not know the answer to this, but certain attacks use something called process hollowing. Are you familiar with the technique? Well, process hollowing, basically you load something like load iexplore.exe, and then you just basically take its code out and put your code in place of it, so it looks like Internet Explorer is running, but you're really running your code. I'm trying to think if this would catch that.
So I think that would be similar to just loading dynamically linked DLLs. If the process, and I guess I don't know if EMET protects based on the process ID or on the process executable name. So if a running process is being hollowed, if Windows still thinks it's the same running process, then I would assume that EMET still thinks it's the same running process and would apply the protections.
Right.
But I really couldn't.
Yeah, most of these protections are memory protection, like memory capture protections.
Correct.
So if somebody's already loading dynamic DLLs into your Internet Explorer, you probably got, and it's not going to do anything.
Yeah.
You probably already have problems.
Yeah.
Yeah, now you're into post-exploitation.
With EMET 3.5, there was an EMET bypass where it just shut it off completely. And the guy who did it, I think it was for one of Microsoft's bug bounty programs, but it was like a Perl one-liner. Shut up. So they are aware of problems, but and I think it was just a really old DLL. You just use this old DLL to attack the EMET directly, and it was done. So, anyone else? Nothing? Well, that's all I got. Thanks, everybody.
Great job, David. I believe that's our last talk of the day. So I just wanted to say thanks again for everybody coming out today. It's been a great day. Thank you, thank you, thank you. Did you guys have fun? Yeah!